14.4 differentials. This is part 1. We have a total differential formula here. df is equal to partial of f with respect to x dx plus partial of f with respect to y dy. And the applications we discuss will give you a good idea of what this is. And let's suppose we have f of xy equals x squared plus 2xy. Find the total differential df. Well, df is going to be the partial with respect to x is 2x plus 2y dx plus the partial with respect to y is going to be 2x dy. And that's all there is to it. That's what's called the total differential. This actually gives you a relationship between change in x, change in y, and change in f. So here's a simple word problem. Suppose f of xy equals x squared plus y squared. x0 is 1, y0 is 2. Change x by 0.1, change y by 0.2. Let's calculate df. We'll get a numerical value in this case. Well, we have df is equal to 2x dx plus 2y dy. That's the x partial, y partial. And let's just plug in and compute. We have limited space here. 2x is going to be 1, and dx is going to be 0.1, and plus 2y, 2 times 2 times 0.2. And if you compute that, that's 0.2 plus 0.8 equals 1.0. Now find delta f. This is actually an approximate change. If you start out at this point, change x and y by each of these, f approximately will change by 1.0. Now let's find that delta f is the actual change. Well, here's what we're going to do. F of 1.0, 2.0 is 1.0 squared plus 2.0 squared. That's 5.0. Now, if we make these appropriate changes, we want to calculate f of 1.1, 2.2. That's 1.1 squared plus 2.2 squared. 1.1 squared is 1.21. 2.2 squared is 4.84. Okay, and if we add that together, we get 5.05. Now delta f is just going to be the subtraction of the two. F of 1.1, 2.2 minus f of 1.0, 2.0, which is equal to 5.05 minus, oh, that's, sorry about that, that's 6, minus 5.0, which is 1.05. Okay, that's actually close to this. This is actually, we'll see it in the next video, this is actually the change along the tangent plane. You can take a curvy surface, take a point here, and you can approximate the change on a tangent. You can put a tangent plane to it. Of course, if you linearize this function, go off along the tangent plane, that's going to be a little different than going on the curvy surface. This is on the tangent plane, that's on the curvy surface. If you look at the concavity of this, the curvy surface is going to increase y, this is real, or z, it's going to increase z a little bit more than the linearization does. Okay, that's all for part 1. We'll be back with part 2 shortly.